Identifying differential usage of isoforms in RNA-seq data can be a tricky problem. A number of groups have proposed relatively complicated methods to identify changes in isoform usage. ArrayStudio uses a straightforward method that we find works fairly well, using ratios of known transcripts in each sample. Basically, for each gene, the RPKM, FPKM, or count data for each isoform is measured as a fraction of the gene's total expression level. A t-test is performed between groups of samples to identify which genes have different transcript usage between samples, irrespective of absolute gene levels between samples. It's important to point out that the p-values reported are not false discovery rate adjusted, but the rankings by p-value will still give you the largest differences in relative transcript usage. This module can be found under NGS, Inference, Differentially Expressed Isoforms. This module expects untransformed, unnormalized FPKM or counts of transcripts. You can choose to analyze all transcripts or a subset and all observations or a subset. Choose the annotation column that specifies the gene grouping and the column in the design table that specifies the sample grouping. Because absolute ratios of transcript expression are used, very weakly expressed genes can have dramatic apparent changes in transcript usage. We recommend applying a cutoff of minimum transcript expression to be considered of 0.1 for RPKM measurements or 10 counts per transcript for count measurement. This can be specified here. Specify an output name and click Submit. The output table can be found under Table, Inference. For each transcript that passed the threshold criteria specified in the module, several values of relative transcript usage between the two groups of tissues will be reported, such as the difference in the ratio between different tissues, the number of samples in the test group that passed the threshold, the difference in total gene expression, expressed as a ratio, and the raw p-value. To start, we should sort by p-value. Now let's filter for genes that have relatively similar total gene expression between the tissues. In the View controller, under Row, choose Gene Expression and specify ratios that are larger than 0.5 and less than 2. We also only want to look at transcripts where the effective sample count is large. Let's say greater than 5. The remaining genes are all relatively evenly expressed between the sample tissues, but the relative transcript usage between them is significantly different. We can directly visualize the difference in transcript usage in the Genome Browser. Right-click a transcript and create a new Genome Browser pane. Let's group our data by site primary, which is the tissue, and now let's zoom out a little to see the entire gene. We can see that although in both tissues this gene is highly expressed, in lung this start is used, whereas in skin this start site is used. We can directly look at differential exon junction usage by clicking on one of the tracks, click Apply to all tracks, and click Show Exon Junction. Blue junctions are known exon junctions, and purple junctions are novel junctions seen in the data. For now, let's hide the novel junctions. Right-click on a track and choose Set Track Properties. Choose the two tracks, and under Show Exon Junction, choose Known. We can see that in lung, only 37 reads spanned this junction, but over 11,000 in skin span this junction.